Good morning, all of you. So today's topic is structure of an atom. So how an atom looks like exactly, what are the particles inside the atom? We are going to study about all those things in this topic. So let's start. So before going into the structure of atom, what is an atom? If you take any substance and start cutting it into tiny pieces, and again cut those tiny pieces further into more tiny pieces, there will be a point where you will reach where you will not be able to cut that substance into other pieces. So that piece which is not, you are not able to cut that, that is atom. But that is not a new concept, that is previous concept, that atom cannot be divided, it is indivisible. But now we know that it is divisible into further particles. We are going to study about that. So what is an atom? Atoms are the smallest particle of any chemical element that can exist. Okay, for example, this is an atom. If you combine atoms, you can form various substances. Those are elements. For example, here sodium element has an atom of sodium, then diamond has an atom of carbon, and mercury has an atom of mercury. So every substance has its own different kind of atom. So what do you see? If you can see atom, what will you see? So there are various scientists who gave their structures. Those are known as models of an atom. So there are three models which we are going to discuss. First is Thompson model, then Rutherford, then Boher's. So what Thompson said, that okay, the atom must look like this. The atom has a sea of positive charge in which negatively charged particles are embedded. It will look similar to a watermelon, where the pink part of red part of the watermelon, that is a positive charge, and black seeds are the electrons. Then came the next scientist, which is Rutherford, and he did a alpha ray scattering experiment. This was the apparatus. So this is alpha ray particle emitter, and this is the screen, and this is the gold foil. So he took a very thin gold foil and passed the alpha particles through this gold foil. So what he observed, that all of the particles passed undeflected through the gold foil. Some of the alpha particles that showed little deflection, and very few deflections were very large. So what, according to him, should have happened is all the alpha particles must have deflected, because alpha particles are also positively charged and this is positive sphere, so deflection should have been maximum. But to his surprise, he got very less deflection and all of the particles passed through the atom. So what he suggested, that Thompson model must not be correct, but the model should look like this, that all of the positive charge should be concentrated in the center, and only the negative charge particles, they are around the center. So only then it could be possible that all of the particles which are positive to charge alpha particle will pass and only few will show deflection. So he gave this model. So what he said, that the atom consists of two parts. One is nucleus, which is very small, heavy body inside the atom, and another is extranuclear part, which consists of electron. And whole mass of the atom is concentrated in the nucleus, and electrons, they have very negligible mass. Then he also said that electron, they are moving around the nucleus like the earth or planet move around the sun. So that is known as planetary motion of electron around the nucleus. So he said that around the nucleus, the electrons are moving like the planet move around the sun. The next is Bohr's model. So in Bohr's model, what he said, that okay, the atom is there and the electrons, they are moving, but they are moving in the fixed discrete orbits, and those orbits has a particular radius from the nucleus and particular energy level, or he also called that energy shells. He also named those energy shells, which we will discuss in next slides. So what is structure of atom will look like? So atom has a nucleus and it has electrons around the nucleus which are moving in the orbits. If you compare atom with the size of football ground, but you will see that in the stadium, if you place a P, that P will resemble the nucleus, the size of nucleus, and the size of this football stadium will be the size of atom. So now you can imagine how small is the nucleus and how far the electrons are moving around the atom. Next thing is the electrons, the protons, and there are also neutrons inside the nucleus of the atom. So what are the charges on the electron? They are negatively charged. The protons, they are positively charged particles, whereas the neutrons, they are neutral particles. What about the mass? The mass of electron is very, very negligible, whereas the mass of protons and neutrons are the main constituents which are responsible for the mass of atom. The next important thing about this is number of proton is equal to the number of electron in the atom, and that is also known as atomic number. Then number of electron and number of proton, they are always equal. And if you add number of proton and number of neutron, then you will get a number that is known as mass number. How electrons are arranged? They are arranged in energy shells according to Bohr. So there is first energy shell, which is closest to the nucleus, then second energy shell, then third energy shell, and then there can be many shells depending on the number of electrons. So in the first shell, it can accommodate only 2 electrons. In the next shell, it will accommodate 8 electrons. And in the next shell, that will have 8 electrons. It also has a rule, which we can study in the next class. So if you take any random atom, suppose here I have took argon atom. So if you see the structure of argon atom, it will have the nucleus of argon that will have proton and neutron, and it will be surrounded by the shells, energy shells of the electron. The first energy shell was also called as K shell by the Boher. Then second shell is known as L, and the third shell is M. So this will continue KLMN like this, and first, second, third shell you can call like this. So here we end up with the structure of atom. Thank you.